Hisham. I am here to talk about Python and maps. Before we get started, since this is about maps, can someone tell me this map? It's a place in Karachi. Can you tell me what place is this within Karachi? Any guesses? I think there's Broti Karachi right here, so you guys should know. Nine, not close. This is not Clifton. No, but I mean, there's no beach here, right? So it's like it cannot be Clifton. Yes. So this is not also part. The map is also, by the way, with Python. There's a package called Pretty Maps, so which you can make pretty maps like this one, right? So again, that's I think a good primer for the session we'll have today as well. So again, it's not Azabad in Karachi, Pakistan, and goes to show. So what this package does is it takes data from OpenStreetMaps, right? Building footprints, the roadways and the other demarcations, and from that it tries to tell you what it is supposed to be like. Ideally, there aren't this many parks in Azabad, but this is what was planned at least initially. Uh, Right. So my name is Hisham. I think most of the people here know me, but for the camera, I'll explain what I do and who I am. So I work at Lipton primarily. It's a tea company. We sell tea. We have 12 global brands, multiple local brands. And so most of my job is managing a team that works on PySpark and builds dashboards and enterprise products on top of that framework on Azure. But a part of my job is also doing these fun experiments, a few of which we'll see today as well, right? At the same time, I also have, I think now it's more of a hobby called Karachi Futures, where we try to apply data science to public policy solutions. So, yeah, agenda overall, this is not really a workshop, it's more of a workshop talk hybrid, right? We'll talk about what geospatial data science is, we'll talk about some key concepts, we will practice some code. So the code is there on your PCs. It's also on my GitHub as well. It's all there. So you don't have to follow along per se, but if you want, you can follow along as well. Just so you get a complete, just so you get a complete grip of it, right? We'll talk about depending on the time we have left over. We'll talk about industry examples as well, right? And then we'll have a Q&A towards the end of it. Yeah. So talking about geospatial, right? So mapping is a very old concept. It was used to be called cartography, right, which is the art and science of making maps and making things representing things on a 3D space over, let's say, a paper or over the globe and whatnot, right? Computerized GI computerized. I think I should probably move the mic a bit down. Better now? Yeah. So computerized GIS came about in the 1960s. So the government of Canada, because they were on land mass, they didn't know what to do with it. They wanted to keep a record of all the natural resources they had with them. So for that, they reached out to a guy, a scientist at that time, a geographer, and he built the first computerized GIS system. Right. So I know there's a lot of definitions out there for this, but to put it at a very very high level, uh, mapping within a computer with a database or with a data structure, you could call it GIS, right? And explain, mapping has been is like an age-old concept, right? So this is a map of Babylon, right? As the Babylonians, as the people from Babylon saw it, right? And this is like very very old. And over here you see that Babylon is the center of the world for them, right? So that is what is represented here. Then you have a lot of propaganda around maps as well. This is a map of World War I between the Central Powers and the Allies, right? Germany versus Austria against France, Italy, and what do you call it? Russia and England, right? So you see like very clear propaganda that the beer is going back and the cats are running away and the lion is running away. The people in the middle are holding guns against them, right? So again, it's meant to prove a point, and that is how it was used historically as well for the most part. Another example, more recent, this map of India. If you publish it on a website, it will get you probably kidnapped, right? Because you see that there's a part of Kashmir which is not really in Pakistan in this map. So again, but this is a map, political map of India as per India, right? So again, just to show you a concept that over history, over time, maps have been used to propagate a certain narrative to people, right? Like most media out there. This is a map of Punjab, and this is from Twitter. So you have over here, basically it's a population density map in like very like I think probably from the 1800s. So what you have here is जहाँ सबसे ज़्यादा लोग हैं, जहाँ काफी लोग हैं, जहाँ कम लोग हैं. So it shows you what parts of Punjab are much more densely populated compared to others, right? Um, and then we come on to what is geospatial data science, right? So typical data science, you focus on the when, who, or how much of a problem. For example, how much tea will I sell next year if I'm a tea company? For example, if I'm a subscription-based business like Netflix, I want to know when my customers will trend. For example, if I am, working in finance, I want to know when a stock price will go up. That's so I can put money into it. But with geospatial data science, that is also a consideration. Like the other three, let's say, pillars of the data or the what we're trying to predict. But the location plays a key part in it, right? For example, place my where should I place my dark store if I'm Food Panda or any, let's say, delivery company that does deliveries? Where should I put my dark store to maximize my GMV for the customers that I have in an area, right? Or if I'm a CPG company, right? If I want to do a BTL activation activities, right? Where should I do the BTL activation? BTL, by the way, means below the line activation. So, like, suppose, for example, you have brand ambassadors or you have a tea stall in the case of Lipton or a tea company at a public area. I can use something like this, right, to tell you, okay, this is where I should place my activation activity to maximize my ROI on what I'm doing or what I'm investing, right? So that is what geospatial data science is in a nutshell, right? Again, you do look at when, who, or how much, but you do focus a lot more on where something is happening, right? I hope that part is clear. Now we'll get into the nitty gritty of it. I will talk about some key concepts around GIS. Is my pace okay? By the way, not you guys. I mean, what about you? Is my pace okay? Cool. Because I talk pretty fast. So we'll talk about some key concepts from GIS. These are not specific to Python, but generally when working with GIS data, with geospatial data, right? So data that you have in GIS is generally of two formats or types. There is data which is vector, data which is in raster format, right? Generally, raster data is much more, how should I say, faster is what they call it. Vector is more corrector. It's like a common punchline that people throw around just to summarize things and make things simple for people to understand, right? And what do I mean by this, right? So vector images, right, will consist of lines, points, and polygons. Right. So let's consider, for example, a road, right? So that will be ideally a vector, let's say, data, right? It will be a polyline, for example. Suppose I want all the points for, let's say, all the retail outlets that, let's say, in Lahore, for example. So each point there will be a separate vector object, right, or a point. Whereas so individual features, discrete coverage, right? So it's more accurate. Either something is there, or it's not there. And I'll tell you what that means when I go to special raster data, right? And then you can have, let's say, each attribute. So imagine an Excel file. Each, let's say, geometry object or each vector data can have multiple attributes to it. I can have as many as 100 attributes for that vector data. Let's say I have a polygon for, let's say, Karachi as a city. I have Karachi ki population. I have Karachi ke, let's say, main ethnicities. I have Karachi's total land cover. These can all be different attributes of one polygon that is Karachi, or one data point, or one vector object that is Karachi. Whereas a raster data, think of it as like a huge, I would say, three-dimensional array, right? Where you have x and y coordinates, which is a lat and long in some cases, in most cases actually. The y-axis is basically, the z-axis is some value. Could be any value, right? That represents something. It could be anything like elevation, could be something like green cover, okay, whether some place is grass or not, right? But the thing is that you can only have one value for one data point for a raster image. So you can have multiple, data points within the image, multiple pixels as they call it, right? Think of any image, any, let's say, screen. This has thousands of pixels, right? Billions, actually, not thousands of pixels, right? And each pixel has, let's say, a positioning, but then relative to the screen, and then it has a color. Right. So in this case, x, y is the coordinate, and then z is the color of the pixel. So that is what raster image is, right? Uh, and again, the key concept here is that it depends a lot on the spatial resolution of the data that I have in play, right? So generally, raster images will come from satellites. Satellites have cameras. Again, I'm simplifying a lot here. Satellites have cameras. Cameras obviously have resolutions, right? So depending on how high powered my camera is, right, I will have data at different resolutions, right? Like for example, I will have data. Let's say there's a satellite called people might not. I don't remember exactly, but suppose there's Landsat, which is a satellite which has been going around since 1980s, I believe, right? So it has a resolution of around 100 by 100 meters pixel. So each pixel is a 100 by 100 meter square grid. Let's assume that for now, and then that square grid has a value. For example, within that square grid of 100 meters, there is, let's say, two different values, right? It can be either or, it can be continuous as well, but in most cases, it's either there or not there, right? I hope this part makes sense. So the higher your resolution is, right, the smaller the cell size, right, and the higher the accuracy, but then it's slow as well, obviously, because if you have more pixels, if you want to visualize it, if you want to do any sorts of analysis on it, it will be much more costly in terms of computing power. It will also be much more slower as well if you have a low powered machine. Whereas if you have an image which is not high resolution, right? Generally, again with photos as well, right? If you have a high res photo, takes time to load, takes time to transfer as well. If you're sending it via some online sharing medium, but then the advantage is it's smaller in size as well. So right, both have their own use cases depending on what you want to do with it. And again, raster data can be continuous and discrete. Discrete would be land cover, right? For example, if I have Karachi or Lahore, for example, I want to see what is, let's say, urban land, which is, let's say, data which has buildings. Then I want to see what is not urban land, let's say fields and open grounds, right? So I can have this classification. Suppose one is urban, two is, let's say, a water body because it's blue. Let's assume that green is, let's say, grass fields, for example. So I can have that at the resolution I have data available. I can classify my data accordingly, whether it's whatever the data type is. It can also be continuous as well. For example, there's something called digital elevation data, right? Which is, for example, how high or low some land is with respect to the sea level, right? A lot of people use this for doing predictions on flood analytics, whether some place will flood or not with rains, right? Which we'll talk about as well in the next slide, right? So yeah, so within raster you have two different, let's say, subtypes. You have discrete and continuous raster data, right? Let's talk about an example which is relevant to, I think, Karachiites. But so just for Lahoris who don't know Karachi, right? Karachi, a lot of it is built on reclaimed land from the sea, right? Which is bound to sink sooner or later under the ground, under the water, sorry, not under the ground, right? So just to show you this, so this is an estimate based on you have rise in sea levels as one data point, then you have the land elevation data that we just talked about, right? So basis on the elevation of the seas and the elevation of the ground in respect to it, right, we can predict by what year what part of Karachi will be underwater, right? So over here, this is 2030. Jumbo Jump is in the water now. Golf Club is already flooding, as we hear. Karachi is gone, sadly. 2070. If this loads, yeah. So more and more is flooding. Let us go to 2000, right? So you will see, specifically around this area, you will see more and more land be consumed by the sea, and then this is 2100, right? Basically, the next century, and a lot of DHA phase 8, which is right now the most expensive real estate in Karachi, maybe, probably, right, is underwater. So good luck with that, right? So again, an example of raster data and what you can do with it, right? I will go back to the deck now. So this is raster data, right? I think this is simple enough to explain. Next, we have vector data. Vector data has three different subtypes in geospatial terms, right? So you have points. Points, as we discussed, is, let's say, individual location points. Could be a tree, could be a bus stop, could be a location of a crime, could be a retail outlet, could be anything, right? Which doesn't need to have space to it. Then you have lines, right? So in Python, it's called a polyline it's called a polyline, right? So your waterways, roads, fences, right? And then you have polygons, which basically is like covered area. You use to represent that, right? And then you have usually data sets that you will find for multiple layers. There's usually maps you will find, especially if you open Google Maps right now, you will see a multi-layered map. You will have points which are your different points of interest, like schools and hospitals. You will have waterways, you will have roadways, and you will have again multiple layers to it, right? Just to give you another example of what that looks like, right? We will now go to OpenStreetMaps. So OSM is basically older than OpenStreetMaps. It's what Google Maps was inspired by, essentially. But basically, it was a university product by some people at some university in the UK. I'm not sure which one exactly. That guy has a podcast as well. I'll try to find it. I'll try to share it with you guys as well. But this is like a basic query on Overpass Turbo, which is a language for querying OpenStreetMaps data. As well, we don't have enough languages for that already. But over here, you can see you have a base layer, which is, let's say, all the roads and the motorways in the different parts of Karachi. Then if I zoom in, I have these individual points, right? And then I have these bigger polygons. I think this is Gatar Bagicha, which is like a huge, I think, graveyard, not a park per se, right? I think it's not a park. I've been, it seems to be a big park for Karachi, right? And yeah, so this is generally when you say multi-layered maps, you have points, polygons, and then lines and waterways and all that stuff here as well, right? There are other types as well, but we'll discuss them maybe in the code part of it. But let's leave it to this for now. Again, just to recap, so you have individual points P1, P2, P3, and so on. And you combine these points. P1 to P2 is L1, line 1. P2 to P3 is L2. P3 to P7 is L3, right? So combine points to get a line. And then when you combine all of them, right, and you have to give it area as well, right, it turns into a polygon, right? So you convert points to lines and then lines to polygons. You don't need to have like necessary lines before you go to polygons, but you can also just go directly from points to polygons as well if you know how to cluster them, right? So that was around data types, right? Within vector data, point, line, polygon. What you also have is you have data types as well, right? How the data is stored within, let's say, a file system or database, right? For that, you have three key types. You have GeoJSON, you have shapefile, and you have KML files. GeoJSON, for people who know how to code, is like JSON files, but with a geography object to it, right? Which tells you the coordinates of either the point, polygon, or line. Shapefiles are traditionally what a lot of GIS databases have data stored in. Not very ideal because it's like whenever you export shapefiles, you have like 7, 8 files. If you miss just one file while sharing all the shapefiles, it doesn't really load, right? And so it's not very handy. Then there's KML, which is mostly used by Google Earth Engine, right? But my favorite is GeoJSON, right? And just to show you an example of GeoJSON data. So if you go to Overpass Turbo here, and I click on data here, and I get the GeoJSON for the data which I saw on the map as well, right? So I have the ID, lat long, and then the tags that for that what do you call it data point as well. And as you can see, I have multiple tags here for each data point. So I have address, street address, whether it's a park and the name of the place as well. So earlier on, what we discussed was that vector data can have multiple data attributes, right? So you can see that in the data as well, right? Where you have multiple data attributes attached to one data point.
Aren't these all just points? I mean, how do you represent polygon?
So polygon will be, wait, I'll have to look for it. So what happens is that there's a way and there's a way ID, and then within each way ID there's multiple nodes. Right? So generally you will have a way, and within that way you have multiple nodes, right? And then that what do you call it, way will reference to the nodes when loading the GeoJSON, right? So it will combine the different nodes to create a polygon, right? So over here you will mostly see, I think it's somewhere here you might see the ways, but that's maybe way down below because mostly you have nodes, right? Generally that's how it works. But when you load it into a data frame, a geodata frame, sorry, then you don't have to worry about that. It automatically reads it and then converts it into geometry objects. We'll see that as well. This is data formats, and then this is so this could be easily a 4-hour lecture on its own. I'll try to keep it very brief, right? The world is not flat; it's not round. It's a bit like a potato, right? Because you have mountains, you have rivers, you have valleys, right? So measuring, suppose if I want to measure, let's say from this building to SDSB, what is the distance? I can do a simple 2D distance on it on a Euclidean scale, right? Because it doesn't really matter because it's very short distance, right? But suppose I'm measuring distance from here to, let's say, Islamabad, I can do what you call habitat distance, which assumes that the Earth is an ellipsoid and you can calculate distance. Suppose if I want to calculate distance from here to New York, right? For that, capacity will come in, right? So the Earth is not properly round; it's like a aloo basically, right? And the way generally what mathematicians do is when they don't really like reality, they assume stuff, right? So in this case, they assume that is an ellipsoid, right? The center of that ellipsoid, right, is called a datum, right? It might not be the center of the Earth, but it's the center of the ellipsoid, and depending on what that datum is, right, it will fit better at some places than other places. Like for example, this example, for example, the center point is here, the ellipsoid. Over here, this is a bad fit, right? I would not use this CRS or this coordinate reference system to measure anything over here, but I will use it for places like these where it's a good fit, right? Again, a very complex topic, but the most common the most common CRS types or CRSs are EPSG 4326 and EPSG 3857. इसको रटा मार लें, right? EPSG 4326 is also called WGS84, right? And this is generally what we see lat long in degrees, right? जबकि 3857 or web indicator is what you generally have when you want to measure distances, because this is in meters, right? Not in degrees, the units, right? So you will convert between this and this a lot, right? And by the way, EPSG stands for European Petroleum Survey Group, because apparently at that point in time, the only people who were really interested in finding out where something is exactly those people who wanted petrol or oil from the ground, because they cannot go on estimates or guesstimates. They wanted to know exactly where the oil is, so that's why they came up with this system. You don't need to remember. You don't need to remember. You don't need to remember all of these, because there's a website called epsg.io where you just put in your lat long. It gives you the relevant EPSG code for that location. But generally, this is how it goes, right? And depending on the country, right, there's different levels of scale here. Like for example, in the US, for example, every province, every state has its own EPSG code for very accurate measurements. So if you're working as a geographer in the US, you're in a lot of trouble with a lot of conversions between different coordinate systems, right? Yeah, I think this is mostly it for the CRS. Let's talk about Python, because this is PyCon, right? So we have different tools that we use, different packages that we use generally in Python for geospatial. So you have GeoPandas, which is like pandas but with the geometry object support. You have Shapely. Yeah, I think this is okay. So you have Shapely, which is used for manipulating geometry objects. Then you have Folium, and so again, there's a lot of stuff that you can work with. Folium is for mapping. OS7x is for playing with data from OpenStreetMaps, right? So there are a lot of options that you can play with. Kepler is like a lightweight GIS tool built by Uber in 2018. It was open sourced. So again, but now I think enough talk. Let's talk about code, right? So I think the code should be in most of the laptops that we have here, right? So I don't think we need to go into those in much more. So again, I'll now go to the Jupyter notebook that I have. People here are comfortable with. Have you guys worked with Jupyter before? I don't think so, right? Or have you? Right. So if you go here, can everyone see my screen?
Yes.
Yeah. So I think I should start because people You're good, sorted?
Yeah.
Okay. Ali, sorted? Anybody? Okay. So first you will install these packages. Right, you have Shapely, GeoPandas, and Folium. So you just press Shift Enter. So for me, these are installed, right? But I'll just run it again just to be safe or just to be sure. And now I will go to the next cell and run this, right? Again, I have some definitions around what GeoPandas and Shapely is. We can get into this later on as well. Again, just to show you one example, so you have lat long, two variables. I put it into a point like data type, right, which is a geometry object, which is a geometry subtype. I run this and I get a point, right? I can see this is a Shapely geometry dot point dot point, so it's a point object. I can get the coordinates from the point, which is the same as this. So generally in Shapely you have x then y, which is longitude and then latitude. Usually we read lat long, so it's a bit confusing. It can be confusing as well for people who are not used to this convention. Then you have another point as well that's called point two. So there's a function to get distance between 2 points, point and point two, right? So it tells me that okay, point or distance, point two, this is this many units, right? So the thing is that Shapely is agnostic of what do you call it, the CRS. It doesn't know whether you're using WebMaker or whether you're using WGS84, so it will just give you the units between, let's say, simple 2D. If you remember go back to inter or high school or A levels, on a simple graph, you find distance between 2 points. This is just that, right?
So, what is the correspond to it? Do they have mappings for meters per unit?
So this is specifically so this is because if you look at this right now, Shapely does not know, right, whether what CRS is this, but we know this is generally lat long, so this is degrees, right? So this is basically this many degrees between these 2 points, right? But Shapely, this is very important, does not know whether this is degrees or meters or kilometers or whatever. They just say okay, this is a simple graph like a 2D Euclidean plane, and I say point one, point two, this is the distance between these 2 points. I can also create, again, the data type for me was line, and create a line from these 2 points, right? So I do Shapely or geometry line string, point and then point two, right? I get this line. It's a line. I mean, that's the type of the object. And if I do line dot length, so this and this is the same, right? Because that was distance between 2 points, and this is basically uh, the length of the line, which is should be the same thing as well. Now I get a third point. I call it point three, right? And I combine all these 3 points, right, to create a linear ring, right, which is this, right? So I have point one, point two, point three, right? But it doesn't really occupy any space. It's not filled in, to put it very simply and plainly, right? If you want to have something which occupies space and is also filled in, I get a polygon, right? So I have simple Shapely.geometry.polygon, shift enter, I get a polygon, right? I can also get a polygon by passing a linear ring into a Shapely geometry polygon object. So again, this and this are the same effectively. So I do this and then I do a simple equals to comparison. It says polygon 2 is equal to polygon, right? So again, this is basic data types from point to polyline to linear ring to polygon, right? Nothing very, I think, complex here so far, right? And so next we read some data from shapefile. So I have, I think the data is also with you as well. I have district boundaries for all the districts in Pakistan, right? So I run it, right? I read this file into a geodata frame. So GPT is my alias for GeoPandas. So I do gpt.read file path, right, and I get this data, which is object ID, province, district. This is the key element here. This is called, it's basically WS84. This is also EPSG 4326. Same thing, right? I just plot it using simple matplotlib, right? I get all the districts of Pakistan in a shape file. Sorry, in a map. Now what I want to do is I want to separate the districts for Karachi over here, right? These are all my districts. These, from what I understand, are districts for Karachi: Karachi Central, Karachi East, Karangi, Karachi Cantonment, Manora Cantonment. Right, so I think around 8 or 7 districts in total for the entire city. I do this. I do a simple is-in filter for the data frame, right? Then I plot it on a map and hope it loads. Yeah. Okay. This is again, now we're using Folium. Folium is a mapping library, right, that we discussed earlier on as well. So I'm basically creating a base object, right, a map object. Then I'm adding a child called shapes, which is a GeoJSON, right, to the parent object called map add child shapes, and I get this, right. So this is Karachi West, Lipton Cantonment, Karachi East, and then Korangi, right. Uh, and then if I want to see what it looks, and suppose, okay, now I want to say, okay, these are different districts of Karachi. I want to combine all of them into one polygon, right? So there are different functions that you can use to, which are built into Shapely, right? That you can apply and use in your code when you're working with Python, right? So I do what we call a unary union, right? To combine all the geometry objects for Karachi district's geodata frame. I do this and I get this one polygon object. So I combine all these districts into one. What do you call it? Into one polygon, right? And you can look at all the options and functions that are available in Shapely through this. What do you call it? Documentation as well. If you want to go through it, this should load in a while. If it takes too long, we can go to. So again, these are all the functions in the user manual for Shapely. Very useful stuff, right? And you'll usually find a function for whatever you want to do. Most things that you want to do within this documentation only for Shapely. Now I want to plot this, so I'll just plot it again using Folium, right? And I have one polygon on Folium for Karachi as a whole, right? Next, and again, I think I missed this in the beginning. So my case study is I want to count the number of schools in Karachi, right? So for that, I will read this GeoJSON file which I've saved. Again, this I got from OSM only, right? So this is saved now, and I do ahead and I see, okay, all these ways and IDs, and then I see in the end I see a geometry object as well for all these locations, right? I do a dot plot, and I can see all these points plotted on a map, right? Good. Now I want to plot them on a Folium map, right? So I have this code with me, right? Are you guys following along, by the way? It's like simple. You just press shift, enter, 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 enter. You don't have to write any code. So this, if I zoom out now, right? I have all the schools in Karachi, right? So I have markers and I have polygons as well for each school. So if I click here, it says this is City School Regional Head Office. This is P.H.S. Girls School. This is, it doesn't have a name, right? Probably not there in the data. This is FPS, Shara Faisal campus. So again, I have data for all the schools in Karachi with me. And now just to add another layer here, right? I want to overlay this with my boundary files for my what do you call it? For my city, right? So I have all the districts in Karachi, and then I have different points within the city and polygons within the city district boundaries, right? And then what I have is wait, let me zoom out. So this is super slow, I know, but because Folium is not meant to have these very, I would say, heavy visuals. You have other libraries for that, like for example, you have Kepler GL for that, for example, which is another package that you can use. But generally, this is what it is like. We would do a bit of data cleaning just to make sure the data is fine or hygienic. Again, some basic ETL stuff. And now this is the important part. Now I want to, so I have the shape files, the boundary files, and I have the original coordinates or points for the schools, right? So now I want to map the shape file to the, what do you call it? I want to map the location of the individual outlet or individual, sorry, school, not outlet, with the district boundaries, right? But before that, I have to ensure that both my data sets have the same CRS, right? So I just do Karachi schools.gdf.crs and then Karachi districts_gdf.crs. So I know, so it says EPSG 4326 here, and name is WGS84, and then it says WGS84 here as well. So I know that both of my data sources have the same coordinate reference system, right? But when I join this, it will throw a warning because the naming convention is not the same. So I know that WGS84 is EPSG 4326, right? But what do you call it? But here the mapping is not exactly the same. It's not 1-to-1, right? So when I go here and I do gpt.special join, right? So you have joins in SQL. This is a join, but let's say a special join. So you have left, you have the districts, and right, you have the schools that the predicate contains. Basically, districts contains schools, right? So I do an aggregate or group by sort of, right? Not aggregate right now, but we'll do it eventually. I'm basically mapping the district to the school over here. So I run this, right? And I just double check to see, okay, are there any schools left outside of my boundary files? And I see that there are 3 schools which are not within my bounds. So that's probably because maybe in my shape files they were Karachi, but maybe in my actual data they were not in Karachi as per the location. Maybe they're slightly outside the shape file, which is fine. It's a very low margin of error. Now I do some basic mathematics. I do a simple group by and count, rename the file from ID to school count, and then I get this data frame. I have by district school count, take for Karachi. I then join this group by data frame. Again, this is a data frame again because we don't have any geometry object here. I join this with my original geodata frame, right? I merge it and I do it on the district. It's a left join just so we're safe and the original district line is not dropped. So I do this, and just to I think just to show you what that looks like. So I have this, and then at the end I have the school count for each district, right? Next, I want to visualize this. So I have this code which creates a choropleth map based on the data which is available to it. Takes the district's GDF, creates a choropleth map, right? And then again, there's different styling options on it that I've applied: opacity, color, other options. And then over that, I also populate I also want a, what do you call it, feather layer as well for the pop-up that will show up, right? So now I visualize this. Let me just take some water. So now I have by district the number of schools that are available. Central is 284, East has 126, South is 249, and then Lipton has 49 schools. Right? This might also be because there's less data there as well. Again, because data is based on open data, not actual data. So there's also a bias there as well inherently, right? So this might not be very true. This is not an actual workflow that you will use in let's say an actual research study. But this is a good example of how to work with OSM data and how to work with geometry objects and shape files. This is the coding part, right? Any questions here before we move on to the examples or right? Has everyone was everyone able to run the code as well? Yeah, no issues there. Feel free to play with it and try to see if you can do something different with it. I mean, you can change the color of a map. You try to change, I don't know, the opacity and have to find, I don't know, the average number of schools, right, by district as well if you want to do that for some reason.
Okay.
Actually, average won't really make sense here. How do you do an average here?
Yeah.
But anyhow, now we'll go on to the industry examples. So over here, the industry that I'm talking about specifically is the consumer goods. Uh,
Where do you find it? Right.
so that I got from OpenStreetMaps or OSM, right? So this is again, I wrote a query here. Like this is for parks. I wrote a query for schools in Karachi, and then I got this data over here, and I downloaded this. There's an option here to export as well. Yeah, export as GeoJSON, right? That's how I got the data for the schools in Karachi.
Give any sort of data.
Yeah, you can. If it's available on OpenStreetMaps. Usually OpenStreetMaps is not as well updated as Google Maps. There's less data as well. There's less PII. It's very difficult to find phone numbers here, for example, or web addresses.
So I think, so I'm imagining you've used OpenStreetMaps to test out a use case, and for real more accurate data, you probably use something like Google Maps for like let's say population data.
Yeah, so for that you could use so population specifically. There's like other open source data sets. There's one maintained by Facebook called the World Pop. So that's what Facebook is. So Facebook maintains it. There's an organization called World Pop which maintains it, and they have data in raster format again because data for population is very huge, right? You cannot put in vector data. So this is just schools in Karachi. That's one small points in polygons. This file I think is around 15 or 10 MBs, right? It's not a small file, right? So imagine this data for population at a very small scale, let's say at a 50 by 50 meter square scale for all the world. Having it in a vector format is not practical. It will not load. You will not be able to work with it, right? Which is why it's showed in a raster data format, right? And there are companies and organizations out there which do that really well. There's Facebook, there's WorldPop, there's Columbia has a lab called CIESN, which does that. But I think answering your question for if you want to do it at scale for the actual client, you would ideally use data from a third-party provider. You would use Google Places API to get data from Google directly. There's a cost to it as well. It's very expensive. Speaking relatively, but this just gives you an idea of how to pull data from it, right? Any more questions over here? No. Okay, now let's go back to the industry example. And the industry here is the consumer goods industry, right? So in the CPG industry, you have salesmen, right, who have sales routes, right? So the way it works is Lipton or Unilever or Nestle will sell to a third party, right, and a third party distributor will sell to a retail outlet, right, and the retail outlet will then sell to a consumer, right? So this is called indirect sales. So indirect sales, your sales reps or your DSRs will go on the ground to different retail outlets, tell them what they have in stock, and sell it to them. Right, simple enough. It is it's a traveling salesman basically, right? So we had a problem where the routes were defined. So over here, each polygon that you see, right, is one route for one day for one sales rep, right? So you can see a lot of overlap here, right? People are going all over the place to sell chai or coffee or sabun or whatever, right? So we built an algorithm using a form of k-means. So I think this, because of lighting, it's not visible right now. It's green on white, so it's not a good choice. So over here, if you can focus, there's no overlap, right? And what we did was we ran, so in k-means, which is a very common clustering algorithm, you can do clustering. But the issue with k-means is that you don't have any what do you call it? You cannot control the number of you cannot control the number of points in a cluster, right? But we ran linear optimization over k-means to give it a range of points in a cluster. So what is the point? A point is one retail outlet, right? So even though we have k-means or machine learning, or we have something running in the background, we're applying linear optimization on top of it to get that range of outlets or range of points in the cluster, right? Then to measure our improvement, and then to calculate the improvement, there's something called convex hulls in geospatial, right, which is like a minimum bounding polygon for a cluster of points, right? So, for example, if you have, let's say, this one route, so the edges or the nodes of this polygon represent the outermost points of the cluster, right? So to measure performance, we said, okay, cluster A was this size seriously, now it's this size. So this is a good heuristic for us to measure our improvement in the cluster size, right? So if it's a small cluster, our salesman has to spend less time traveling, right? He can spend more time selling, right? This means less fuel as well that he spends on his bike, right? So it's a win-win for everyone involved. The next example is relatively straightforward. So again, by the way, this data is from like a third-party provider from, I think, maybe 8 years ago, so it's quite dated, right? Uh, so again, just to show you the example of what it looks like, but then again, we have done this exercises for different companies in the past, and it kind of works in most cases. So you have the current active outlets, right? You have, let's say, suppose you did a survey simply to see, okay, what new outlets do I have on the ground, right? So I got those survey outlets. I overlaid them to see my high potential areas, right? So I got a grid of 250 by 250 meters, made a heat map to see, okay, this is where I have more outlets covered, and this is where I have more new outlets. So I got that, and I was able to then get this 3D map as well based on estimated turnover from those new outlets, right? Relatively simple use case. We did this as well right now for schools, right? We did a simple special join, simple similar stuff here as well. So you have to make the grid yourself, which is not very complex. But again, another example. Yeah, so this is something which we did for Unilever. Yeah, so Unilever, so in some companies, the way kind of they also do very similar stuff, right? So there's my back button. You know, yeah. And then we have so generally the way it works is that you classify outlets as either urban or rural. And the way in some companies the incentive is driven with, okay, if you sell more to rural outlets, right? Because you want to expand there, right? And the way it's done is that somebody manually goes and defines that, okay, this outlet is rural, this outlet is urban. You cannot rely on government boundaries because government boundaries are often politically motivated, right? So you cannot rely on the government's definition of what is urban, what is rural. So we made our own definition using something called using something called local outlier factor or LOF, right? We were able to create these clouds or these polygons, right? And what we did simply was that, okay, if it's an urban outlet, right, it should be within this polygon, right? But if it's a rural outlet and it's tagged within the polygon, it's directly tagged, which is the red outlets, right? So this way you can easily find out what is the hygiene in your data as well that you're getting from the field force or the people on the ground, right? This and then this is something which is also very interesting. So the way it works is that you have different distributors with different boundaries. They sell to different people, right? But that is also very inefficient the way to do it, right? Because sometimes you will have people sell to a outlet which is very far away from the distribution, and there are distributions which are closer by or close to the actual distributor, but somebody from very far away is going and selling to it, right? So we did something very simple. We did something called Voronoi tessellations, essentially, right? Where the center point was the distributor. Then you had these what do you call boundaries for the distribution, right? And everything which was within the boundary for the distribution. This is the ideal boundary in 2D space, by the way. This is not given the road network or anything else. So anything which is within the boundary or the cell for that distributor, right, is blue, right? And these red outlets basically are those which are, suppose this outlet is close to this distributor, but it is not serving it. Somebody from far away is coming and serving this outlet. It's a waste of money, time, resources, all of the above, right? Uh, so just to show you what the solutions are, since you have time left, I will go here and I'll just open this blog on Medium, right? If it loads. So this is like a very good, not this one. This is a very good visual for it, right? So let me zoom out. Let me zoom out more. So these points create these boundaries, fill the color, and you have these boundaries, right? So it's based on the closest proximity. So everything within that boundary or that polygon is closest to that point, which is the centroid for that cell, that polygon, right? So this is the basic principle here at play here. Again, very simple concepts applied to real use cases. Again, using geospatial ways of working, right? Uh, and then I think that is it from my end. Any questions?
So I have a question. So when you were mapping for your example for the university, when you were mapping those polygons, you said you ignored the road networks. Wouldn't those be more relevant than the polygons themselves? Because
In which use case? This one?
I think
Yeah. So there is a way for that as well. There's something called an isoclone that you can use. So this was meant to be like a very basic, let's say, heuristic model, not a heuristic, but like a basic Bayesian model to show somebody that okay. And again, because there's a lot of nuances involved in this entire space, so we weren't telling them that okay, just go and change it today, right? We're saying okay, look at this. This is not right. Maybe go ahead to this guy to have a discussion with him, right? And see okay, does he want to serve these outlets and those outlets? Because again, their margins and their what do you call ROI is based on what outlets they serve. Might be that this outlet is very low value, right? And this guy doesn't want to go there. He's like, why should I spend money and time to go there? But behind this to show to people in the leadership team, show them okay, this is your loss efficiency with the network, right? And because all these companies they reimburse part of the cost for the distribution, right? Whether it's the salesman or the transport or the fuel, right? So it's a cost for them as well, not just the third party which is selling. Yeah. Any more questions or are we good?
good.
Yeah, we're good.
Thank you.